Now moving on to our third chapter, that is even numbers, odd numbers, prime numbers, composite numbers, twin primes and co-primes. So what are even numbers? As I believe all of you already know, what are even numbers? Numbers which are divisible by 2. So the numbers which are divisible by 2 are even numbers. For example, 4, 14, 18, 298, 32 and etc. So what is the characteristic of these numbers? The characteristic of these numbers are that even numbers ends with either 0, 2, 4, 6 or 8. Whatever even number you see, it will always end with 0, 2, 4, 6 or 8. So if I write any random number, let's say 5724. So is it an even number? Yes, it is an even number because it is ending with 4. So as it is ending with 4, it is an even number. Let's take another example, 5000. 5000, is it an even number? Yes, because it is ending with 0. So all the numbers which ends with either 0, 2, 4, 6 or 8, those numbers are called as even numbers. Now the second category of numbers is odd numbers. So any number, all the numbers can be either even or odd. So numbers which are not divisible by 2 are called as odd numbers. Numbers which are not divisible by 2 are called as odd numbers. For example, 3, 7, 9, 51, 79. So basically any numbers which are ending with, see, we have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So numbers ending with these digits are even. So odd numbers ends with 1, 3, 5, 7 or 9. So any number which is ending with either of these digits will be considered as odd number. And please don't have this misconception that all the odd numbers are divisible by 3. It is not true. Such that, for example, 23 is an odd number, but it is not divisible by 3. So generally students have this misconception that if even numbers are divisible by 2, odd numbers are divisible by 3, which is incorrect. Even numbers, this is true that even numbers are divisible by 2, but it is not necessary that all the odd numbers will be divisible by 3. Okay, they may or may not be divisible by 3, but definitely they will not be divisible by 2. So let's take another example, some random example, 57. It is ending with 7. That means it is an odd number. I hope you are clear about this. The next classification comes as prime numbers and composite numbers. Now this is one of the most important classification. Prime numbers. What is the meaning of prime numbers? See, let's take a number 10. 10 is divisible by 1, 2 and 5 and 10, right? Let's take another number 20. 20 is divisible by 1, 2, 4, 5, 10 and 20, correct? So see, what are these? These numbers are called as factors of 20. 1 is a factor of 20, that means 20 is divisible by 1. 5 is a factor of 20, that means 20 is divisible by 5. 10 has a factor 5, that means 5 can divide 10. Now take another number 19. What are the factors of 19? 1 definitely. 1 is a factor of every natural number. In fact, 1 is a factor of every number. Every number is divisible by 1. But can you think of any other number between 1 and 19? See, 19 is also a factor of 19. 19 is divisible by 19. But is there any other number? No. Let's take another example. 23. 23, again, 1 is a factor. Is there any other factor of 23? 23, of course. But any other than 23 and 1? No. So see, so definition of prime number is, prime numbers are all those numbers which have only 2 factors, that is 1 and the number itself. 1 and the number itself. Prime numbers are all those numbers which have only 2 factors, that is 1 and the number itself. Now prime number contain a lot of importance throughout mathematics. Prime numbers are very useful, and it is very important that you learn all the prime numbers at least between 1 to 100. Between 1 to 100 there are 25 prime numbers. Between 1 to 100 there are 25 prime numbers, and it is very important that you learn all the prime numbers because they are used time and again in mathematics for various options. Like for example, for finding LCM and HCF, prime numbers are very important, and to find factors and multiples of any numbers, prime numbers play a very important role. So let's write all the prime numbers between 1 to 100. Now the first number is 1. Now what about 1? Is 1 a prime number? Or the numbers which are not prime are called as composite. The numbers which are not prime are called as composite. So what about 1? Is 1 a prime number or a composite number? It is a lot of 1 presents a lot of confusion because the definition of prime numbers is 1 and the number itself. Here both these things are 1 only. So what should we consider? 1 as the prime number or a composite number? So mathematicians took a middle path. The number 1 is neither prime nor composite. Please keep this in mind and make a note of it in your notebook as well, that the number 1 is neither prime nor composite. Now come to 2. So 2 is a prime number because 2 has a factor 1 and 2. 2 is divisible by only 1 and the number itself, that is 2. So 2 is the smallest prime number, and it is also the only even prime number. Please make a note of this point as well. 2 is the smallest prime number as well as it is the only even prime number. Fine. Then comes 3. 3 is also a prime number because 3 is divisible by only 1 and 3. 3 is not divisible by 2, so 3 is a prime number. Then what is the next number? 4, but 4 is divisible by 2, so it is not a prime number. Then comes 5. 5 is divisible by only 1 and 5, it is a prime number. 6, it is divisible by 2 and 3, it is not a prime number. 7, yes, 7 is a prime number because it is divisible by only 1 and 7 and no other number. Then 8, yes, 8, no, it is not a prime number, it is divisible by 2 and 4. 9 is again not a prime number, it is divisible by 3. 10 is not a prime number, it is divisible by 2 and 5. Then comes 11. 11 is a prime number, yes. So I think you understood how to judge whether a number is a prime or not. So 12 is not, 13 is yes, 14 is not, 15 is not, 16 is not, 17 is yes, 18 is not a prime number divisible by 9 and 2. but 19 is a prime number. Same way 20 is not a prime number. Basically any even number other than 2 will not be a prime number because all the even numbers are divisible by 2. So 20 is not a prime number. 21 is divisible by 3 and 7. It is not a prime number. 22 even, not a prime. Next number comes as 23. 23 is a prime number. 24 even, not a prime. 25 is divisible by 5. 26 even, not a prime. 27 divisible by 3 and 9, not prime. 28 even, not prime. 29, yes, 29 is a prime number. 30 even number, not prime. 31, yes, it is a prime number. 32 even, not a prime. 33, it is divisible by 3 and 11. 34, it is an even number, so not a prime. 35, it is 5 and divisible by 5 and 7, so not a prime. 36 is an even number, not a prime. 37, yes, it is a prime number. 38, no, even. 39, it is divisible by again 3 and 13, not a prime. 40 even, so not a prime. 41, it is a prime number. 42, it is an even number, so not a prime number. 43, yes, it is a prime number. 43 is a prime number. 44, it is even, so not a prime. 45 divisible by 5 and 9, not a prime. 46 even, not a prime. What about 47? Yes, 47 is a prime number. 48 even, not a prime. 49 divisible by 7, so not a prime. 50 even, so not a prime. 51, it is divisible by 3 and 17, so it is not a prime number. 52 even, so not a prime number. 53, yes, it is a prime number. 54, no. 55, no. 56, no. 57, no. 58, no. 59, yes. 60, no. 61, yes. 62, no. 63, no. 64, no. 65, no. 66, no. 67, what about 67? Yes, 67 is a prime number. 68, no. 69, no. 70, no. 71 is a prime number. 72, no. 73, yes. 74, no. 75, no. 76, no. 77, no. 78, no. 79, yes. 79 is a prime number. 80, no. 81 is not a prime number. 9, it is divisible by 9. 82, no. 83, yes, 83 is a prime number. 84, no. 85, no. 86, no. What about 87? 87 looks like a prime, but it is divisible by 3. So 87 is not a prime number. 88, no. 89, yes, 89 is a prime number. Now 90, no. 91, again 91 looks like a prime number, but you can see that it is divisible by 7 and 13, so it is not a prime number. 92, no. 93, no. 94, no. 95, no. 96, no. 97, yes, 97 is the highest 2-digit prime number. 98, no. 99, no. 100, no. So basically I have written all the prime numbers from 1 to 100 and they should be 25 in number. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Perfect. So we have 25 prime numbers in total, and it is very important that you remember all the prime numbers between 1 to 100. There are prime numbers after 100 as well. Prime numbers keep on continue. But it is important that you learn at least these 25 prime numbers. Now all the numbers which are not prime are composite. So you can see between 1 to 100, if you know the prime numbers, you already know the composite number. So one is neither prime nor composite, so we cannot write 1 as the composite number. 2 is a prime number, 3 is a prime number, now 4 is a composite number, similarly 6 is a composite number, then 8, then 9, and then 10. So in the same way you can write all the composite numbers between 1 to 100, but there is no need to remember them. As you already know the prime numbers, you automatically know the composite numbers. What is the meaning of two terms? What is the meaning of twin prime and co-prime? They are just mere definitions, but still it is important that you remember them because they are sometimes asked in the question. However, there is nothing new or different in these two definitions, but still students tend to confuse between both of them. So twin prime means pair of prime numbers having difference as 2. For example, 11 and 13. 11 and 13, they are twin primes because they have a difference of just 2. Another example can be, let's think, what can be another example? 11 and 13, or 3 and 5, or 5 and 7. So these are pair of twin primes. I hope you got the idea. So both these numbers should be prime numbers, as well as the difference between these two numbers should be only 2. Can we write any other twin prime number? Or I hope all of you got the idea. So you can write it, right? And what is the meaning of co-prime? Co-prime means the pair of numbers are mutually prime, which means they do not have any common factor other than 1. The numbers need not be prime numbers. Now what is the meaning of this? Let's say, let me take two numbers, 3 and 4. Do they have any common factor other than 1? No, they do not have any common factor other than 1. Let's take another number. Let's say 9 and 17. Do they have any common factor? No. Other than 1, they do not have any common factor. Let's take another number. 9 and 10. Is 9 and 10 divisible by any number other than 1? No. So we can say that these are the pair of co-prime numbers. Individual numbers need not be prime. Please pay attention. Individual numbers like 9 is not a prime number, 10 is not a prime number, 4 is not a prime number. So in the pair of co-primes, it is not necessary that your individual numbers are prime numbers, but what is necessary is that the pair should not have a common factor other than 1. Fine. And in case of twin primes, both the numbers should be prime numbers with a difference of 2. So that's why the word twin prime is important. Prime means both the numbers are prime and they are like twins. They come very near to each other with a difference, with a gap of 2. Okay, and co-prime means that they are mutually prime numbers. They are mutually prime numbers, which means they do not have any common factor other than 1, but individual number need not be prime. And in case of co-prime, please note a very important point, that every consecutive number are always co-prime. I'm repeating it. Every consecutive number are always co-prime. What is the meaning of consecutive number? Like 8 and 9, they are consecutive numbers. 7 and 8, they are consecutive. 10 and 11, they are consecutive. 23 and 24, they are consecutive. So every pair of consecutive numbers will always be co-prime because they will never have any other common factor other than 1. Are you getting my point? So, and it is not necessary that only consecutive numbers are co-prime. You can think of any two numbers, if they do not have any common factor, they will be co-prime. So let me tell you, 91 and 8. They do not have any common factor other than this. See, 8 have factors 1, 2, 4 and 8. What are the factors of 8? They are 1, 2, 4 and 8. What are the factors of 91? It is 1, 7, 13 and 91. So they do not have any common factors other than 1. So we can say 91 and 8 are co-primes. Although 8 is not a prime number, still the pair of 91 and 8 is co-prime. Now moving on to questions, let's do some questions. So the first question is, which of the following pairs are not twin prime? So the options are 197 and 199. But we don't know if 197 and 199 are prime numbers or not, because we have just studied the prime numbers up to 100. Fine. So let's leave them for a while. 11 and 13, yes, they are twin primes. 3 and 5, yes, they are twin primes. What about 599 and 600? My friends, they are co-prime and they are not twin primes. See, 600 is definitely not a prime number. It is an even number. So 2 is the only even prime, right? So 600, as it is an even number, it is definitely not a prime number. So the answer is option number D, because they are not twin primes. So even if we didn't know whether 197 or 199 was a prime number or not, we were able to do this question. Fine. Now let's move on to question number 2. What is the sum of 3 prime numbers succeeding and preceding 55? It means, succeeding means before 55, succeeding means after 55 and preceding means before 55. So what are the 3 prime numbers before 55? They are 53 from our list. I'm just try to remember the list, and from that try to find out what is the numbers, 3 prime numbers preceding 55. And from the list we can get they are 53, 47 and 43. So the numbers preceding the 3 prime numbers preceding 55 will be 53, 47 and 43, and their sum will be 143. Fine. And what are the prime numbers, 3 prime numbers succeeding 55? Succeeding means after 55. So after 55, the 3 prime numbers will be 59, 61 and 67. 59, 61 and 67, and their sum is going to be 187. But the question asks the sum of 3 prime numbers succeeding and preceding 55. That means we have to find out the sum of these 6 prime numbers. So the sum of these 6 prime numbers will be 143 plus 187, which is 330. So the answer is 330. I hope all of you got this question. So basically in this question, if we remember the list of our prime numbers, we can do this question. Now moving on to third question. What is the difference between sum of composite numbers from 11 to 20 and sum of prime numbers from 1 to 10? So let's first write the composite numbers from 11 to 20. So 11 to 20, the sum of the composite numbers will be 12, 14, 15, 16, 18 and 20 itself. So the sum of composite numbers from 11 to 20 will be the sum of these numbers. See, 11 is a prime number, so I have not included 11. Then 13 is a prime number, 17 is a prime number. So 12 plus 14 plus 15 plus 16 plus 18 plus 20. So what is the sum of these numbers? So see, 2 plus 4 is 6, 6 plus 5 is 11, 11 plus 6 is 17, 17 plus 8 is 25, plus 0 is 25. So 5 over here and carry 2. So 2 plus 1 3, plus 1 4, plus 1 5, plus 1 6, plus 1 7, plus 2 9. So the sum of these numbers is 95. And this, now the next part of the question is sum of prime numbers from 1 to 10. From 1 to 10 the prime numbers are 2, 3, 5, 7 and that's it. So from 1 to 10 the prime numbers are 2, 3, 5 and 7. So their sum will be 2 plus 3 5, 5 plus 5 10, 10 plus 7 is 17. Fine. But there is still, we have to find out the difference between. What we have to find out? Difference between sum of composite numbers from 11 to 20 and sum of prime numbers from 1 to 10. So now this is a sum of composite numbers from 11 to 20. This is the sum of prime numbers from 1 to 10. Now what is their difference? So basically what we need to do for the answer is 95 minus 17. So what is 95 minus 17? It will be 78. So this is our answer. Moving on to next question, question number 4, which is the 17th odd number after 2, 3, 4, 8. The 17th odd number after 2, 3, 4, 8. So this question is, maybe by reading it for the first time, it may look difficult, but it is actually a very easy question. So if I ask you, what is the gap between any two consecutive odd numbers? It is 2, right? If one odd number is 3, the next is going to be 5 and the next is going to be 7. Same we can say for the gap of two consecutive even numbers. It will also be 2. So 2, 4, 6, 8, right? So after a gap of 2, every even number comes, and same is for the odd number. After a gap of 2, every odd number comes, right? So what is the, let's find out what is the next odd number for after 2, 3, 4, 8. It will be 2, 3, 4, 9, right? So basically the first odd number after 2, 3, 4, 8 will be 2, 3, 4, 9. Now, but our question asks us to do the 17th odd number. It asks us to find out the 17th odd number. So we already found out the first odd number, correct? Now for the remaining 16, won't it be 2, 3, 4, 9 plus 16 into 2? Because see, we have to find out the next 16 odd numbers. They are going to come after a gap of 2, right? So after 2, 3, 4, 9, it will be 2, 3, 5, 1, then 2, 3, 5, 3. So after a gap of 2, every odd number will come. So in total, how many gaps of 2 we are creating? So to find out 16 odd numbers, we have to add 16 into 2, correct? Because if we are finding out 16th odd number after 2, 3, 4, 9, the gap we are creating will be 16 times 2. So it will be 16 into 2, that is 32, plus 2, 3, 4, 9. So the answer is 2, 3, 8, 1. So this is the 17th odd number after 2, 3, 4, 8 and 16th odd number after 2, 3, 4, 9. I hope you got it. Or else let's do question number 5. This is also of the same type, but instead of asking an odd number, it is asking us an even number. So we have to find out the 11th even number previous to 3, 4, 2, 6, 5. So what is the first even number previous to 3, 4, 2, 6, 5? It is 3, 4, 2, 6, 4, right? 34,264. Now we have to find out the remaining 10th. Now we have to go back 10 times, right? We have to go back 10 times 2 to find out the 10th even number after 3, 4, before 3, 4, 2, 6, 4. I'll repeat it again. We have to find out the 10th even number before 3, 4, 2, 6, 4. So we have to jump 2 10 times. We have to take a jump of 2 and 2 and 2 and 2 and 2. How many times? 10 times. So basically we are going back, so therefore a minus sign, and we are taking a jump of 2 10 times, so therefore that's why I am multiplying 10 into 2. So the answer for here will be 10 into 2 is 20 and 3, 4, 2, 6, 4 minus 20 will be 3, 4, 2, 4, 4, right? But the answer, this is not the answer. What does the question ask? The question asks us to do the double of this number. What is the double of 11th even number? So this is the 11th even number before 34265, and the double of this will be multiplied by 2. So it will be 88486. So our final answer is 68488. So I hope all of you have understood this questions, and all of you will practice more questions at home, which we will provide you after the video. Thank you very much.